a bit about our TLB, okay, which is the uh, important point, which was translation look aside buffer. The TLB is essentially a cache, okay. What does it cache? It's a cache for the page table, okay. Remember, a page table, well, it maps VPN into PPN, okay? And hence a TLB basically caches the entries, and I say entries from the page table. So that's what it does. It's a cache, but it just copy based on access. It accesses them in here. Now it is different from our regular data caches, meaning that if you have like data cache, like L1 data cache, and what do? You access, you have an address, you check, you go with the address, and you try to read the data. Okay, you check whether and it can then create a cache miss and etc. And in the case of a TLB, what we do is instead of an address, then we use the PPN, okay, and then we try to get the PPN, okay. That's what it does. And the size of TLB is often given as stated in number of entries. When I say entries, like we have this page table, right? And how many of these page table entries are cached, okay, in the TL. That's what we discuss. And so what I will do is, like, let's say that we do let's say that we have a int a, say number. So let's say that I have this many it's a big array, and then I am accessing let's I, and then for I equals 0, and then I less than whatever 6 I plus, and then I'm saying that say that sum plus equals say AI. Okay, so in this one now, how many page table entries? So here's the question here, okay? Of many TLB misses. Well, maybe let me do this. Okay, what is the TLB miss rate? Okay, so so we don't let's say that our TLB maybe contains a number of basically entries. Okay, and so what you can do is, in this case, let's look at the addresses. Like we start our access is essentially A0, A1, etc., right? And when we access the first one, it will be a miss. It will be a TLB miss, okay? Because the address for this one number, then here's the address. So if I look at my A, okay, then here is my address miss rate if the page size is 4 kilobytes. Okay, so let's say that this is the address of my A, and then in here, then this is again 48 bits, right? And then I will have basically 12 bits here as the offset, and here's my VPN. And with this, then when will I have my next one? So when I have like when I say this is A00, okay. If I look at A01, okay, then its address will be this, okay. This portion will differ, okay, but this one will be the same, okay. The VPN here, okay, the VPN of this one, okay, will be the same, but these will be different, okay. So the offset will be different. This one offset, let's do this in here. So this is VPN, okay, of A0 will be the same as VPN of A01, okay, but not that VPO of A0 will not be the same as VPO of A01, right? Okay. So based on this, then at which A, will I have a different VPN? So I have A of something here. So, well, it depends. Like, so it means that, like in this case, my A, it has 4 bytes, right? Its size of AI is, say, 4 bytes. Since I have my page size, so within one page, I will have in one page, you will have 100. Let's actually in one page you will have 2 to the power 12 bytes, and then divided by 2 to the power 2, it means 2 to the power 10 entries. So you will have, when I come to 1024, okay, then you will have a different VPN here. So it means that VPN of a 1024 will be different from the VPN of A0. Okay, and for all the other ones it will be the same. So the TLB miss rate will be actually 1 over 1024. Even if we even if the TLB has 1 entry. So this, of course, why do we need a large TLB? It's because you are accessing A and B at the same time. Okay, then you will get a lot of things. So this is why. But if you are accessing the same thing, and if you keep this the VPN to PPN translation, then you should be okay.